Hi everyone, this is the AM transmitter I made by myself, and I will tell you about it detailedly. First, this one here is the AM signal generator. You can see here is a headphone plug which can plug into the computer or my phone here, and this is a audio plug, and the audio signal comes in from here and through this little transmitter. It's a coil, and it will block the high voltage from here going to my computer, and the audio signal comes from here to this stage amplifier. You can see here are two 6-in tubes, vacuum tubes, and these four there are two trailed in one 6-in vacuum tube, and so here are four trails, and they are in series, not connected directly in series, but the circuit is the signal goes through all these four trails and is put out from here to this EL34 tube to amplify its power, audio power, and the audio power goes through this small transformer here and goes to that bigger transformer here. The second winding of this big transformer is in series with this little crystal oscillator here. This is one 12 megahertz crystal oscillator, and its power goes from here, the switch mode power supply. You see that the green light is on, and it powers all these three filaments and one oscillator here. So it's the I don't know how to say it in English, but the audio signal, amplified audio signal, goes through the bigger transformer, which is in series of the power of this oscillator. So the audio signal will be put on the RF signal, which comes out from this capacitor here. The capacitor in series with the oscillator, so it isolates the high voltage, the 300 volt high voltage from here. So only the RF signal goes out through this yellow wire here, and I didn't connect it to my amplifier here because this signal is too small. I tried yesterday, it's too little, and it can't drive this RF powered amplifier here. And as you can see, here is the power stage, which provides the 320 volts DC to the anode of these tubes here. And that is a 4-bridge rectifier here, 2 capacitors and 1 inductor here. A very simple circuit. And so let's go next to my RF amplifier here. This is my RF amplifier. It's the great grounded type RF amplifier, which uses an FU19 vacuum tube here. 2 trails there, but it's very special. I turn on the light and show you about it clearly. You can see that it has 2 anodes here, 2 plates. You see, 2 plates, I connected them together, use as one tube, okay? And you can see that it only has one cathode here, the white one. Only one cathode here, right? And there are two grades, and I connected them together under this ceramic. I don't know how to say it in English. Sorry. And okay. Here is a power supply for this RF amplifier stage, and the power comes from here. You can see here the plug here, right? The power goes in from here. You can see the voltage is about 230 volts. So here are two for a half bridge rectifier. Only 2 diodes here. You can see them, right? 1N5408, 1000 volts, 3 amps. Okay, and each line of the capacitors are this line here, 2500 microfarads, and this one 2500 farads too. Each line is charged up to 330 volts, about 330 volts. That is equal to root 2 times 230 volts, right? And these 2 lines are connected in series, so we can get about 660 volts here. I wrote one minus here. Here is minus, and this one here is positive, negative, positive. Okay, positive, negative, and I have to film capacitors here to filter the RF signals from coming out into other things. Okay, and there are 2 100 kilo ohm resistors in series, paralleled with each line of capacitors to discharge the capacitors after I disconnected the power supply. Okay, and alright, the high voltage goes in the power stage through these 2 wires, this positive, this negative, and goes to the anode of this tube through the this inductor, the high frequency shunt here. Oh, not shunt, I don't know how to say it in English, sorry. And this is a high voltage ceramic capacitor. It can handle about 5,000 watts. Okay, and it works at 5,000 kilovolts, and it is rated about 1,000 picofarads here. And the RF signal goes out from here, another side of the capacitor, into this coax cable here, 50 ohm cable here, into my self-made standing wave ratio meter here. You can see I printed this this thing with a color printer here, and we can read the power through the meter. Okay, and the RF signal goes out through this standing wave ratio meter into my antenna outside. Okay, the antenna is not very good. It doesn't match my signal, so I need to change my antenna tonight to have a better standing wave ratio, a lower ratio. Okay,